Determine which of the statements in 15 through 19 are true and which are false. Prove each statement directly from the definitions and give a counterexample for each false statement. For a statement that is false, determine whether a small change would make it true. If so, make the change and prove the new statement. Follow the directions for writing proofs on page 173. The difference of any two rational numbers is a rational number. Well, let's play around with the algebra here for a little bit. If I have an arbitrary rational number a over b, and I subtract that from another rational number c over d, the question is this going to be a rational number? We could rewrite each fraction with a common denominator by multiplying the left fraction by d over d, so that would be ad over bd, and then we could change the second fraction by multiplying that by b over b, so that would be bc over bd. And then we can combine these fractions to get one fraction, ad minus bc all over bd. And this will be the conclusion because this numerator is an integer and the denominator is an integer that we know is non-zero since neither b nor d is 0. So now that we have a brainstorm of what this proof should look like, let's formalize it. So we're making a claim about any two rational numbers. So what's being quantified here is two rational numbers, and the quantification is universal, any two rational numbers. So let's instantiate two arbitrary fixed rational numbers. Let R and S be rational numbers. Now, we don't know what rational numbers R and S are, but they are arbitrary rational numbers, and we can use different variables to represent these rational numbers from the definition. Ignore that last statement. So now let's unpack what it means to be a rational number. According to the definition of rational numbers, R equals A over B for some integers a and b, and b does not equal 0. And we could say S equals C over D for some integers c and d, and d does not equal 0, and d does not equal 0. The reason we use different letters for these two rational numbers is because if we both labeled R and S as A over B, then they would be the same rational number. And the thing we're trying to prove is that the difference between any two rational numbers is a rational number, not just two of the same rational numbers. We're not trying to show that the difference between two of the same rational numbers is rational. We want to ensure that both rational numbers are flexible in what they could possibly be. So now let's consider the difference between R and S. We can use substitution to rewrite R minus S as A over B minus C over D. And that's by substitution. By algebra, we can simplify this to be A over B minus C over D equals AD over BD minus BC over BD. And we can keep going with the algebra part by combining these fractions with a common denominator and rewrite this as A times D minus BC all over BD. So we have to justify a couple things. We have to show that this whole fraction is in fact a rational number. How do we do that? Well, we need to show that this is an integer and that this is an integer that's not equal to 0. So let's clarify why that is. Since integers are closed under multiplication and subtraction, we could say that AD minus BC is an integer. Similarly, BD is an integer. We also need to demonstrate that BD is not equal to 0. But since B does not equal 0 and D does not equal 0, then BD does not equal 0. So now we've demonstrated that R minus S equals this integer divided by this non-zero integer, which means that by definition of a rational number, R minus S is a rational number. And that's what we wanted to show, that the difference between any two arbitrary rational numbers is going to be a rational number. Thanks everyone, and I'll see you in the next video.